To explain linear programming problem by graphical methods. Before we go for the problem, let me explain the basic concept of linear programming problem. Linear program is a mathematical. I'm going to explain linear programming problem by using graphical methods. So before we go for the problem, let me explain basic concepts of linear programming problem. So linear program is a mathematical programming technique used to optimize the performance. There are two major objectives. First one is minimization and second one is maximization. Minimization is what means total cost. That is the main objective of minimization. And second important objective is minimization. So these are the major is any organization. So here in graphical method there are different models are there. With the help of LPP graphical methods you can able to find the optimum solution. In LPP we have a different methods, for example graphical method and simplex method, dual simplex method and big gum method. These are the different methods are available, but graphical method are applicable only to variables. If you have two more than variables or graphical method is not suitable. Here I am going to explain minimization and maximization. First one we will discuss about maximization. So let explain video. Problem, solve the following LPP using graphical method. This is the problem. Maximize z equals to 12x1 plus 16x2. So this is the objective function of the problem. Subject to constraints are given. First one 10x1 plus 20x2 less than or equals to 120, and this is the first constant, and second constant 8x1 plus 8x2 less than or equals to 80. These are the two constants. Now we have two constants. Our objective function is maximization z equals to 12x1 plus 16x2. So first of all I will explain solution. The first 1 plus 20x2 less than or equals to 120. This is the first constant, and second constant 8x1 plus 8x2 less than or equals to 80. This is the first and second constants. We need to find out the value for x1 and x2. Value should be greater than equals to 0, which means positive value only. Greater than or equals to 0 means positive. Just convert the first constant into equation format. 10x1 plus 20x2 equals to 120. This is the first equations. So now we have to find out the value for x1 and x2. We need 2 points plot in the graph sheet. So first thing you need to take x1 as 0. So x2 is we don't know. So x1 value enter into the first equation. We have to substitute x1 value and x2 we don't know. So as it is 20x2 equals to 120 and x2 equals to 120 by 20. x2 equals to 26 the 120. So x2 equals to 0 and x1 what? So apply this above equation same as it is. 10x1 plus 20x2 equals to 120. So 10x1 plus 20 into 0 120. 10x1 equals to 20 into 0 0, so 120. x1 equals to 120 by 10. x1 equals to 12. So x1 equals to 0 and x2 equals to 6, and x1 equals to 12 and x1 equals to 12 and x2 equals to 0. So now we had 2 points. there are 2 points is there, x1 equals to 0 and x2 equals to 6. So another point, x1 equals to 12 and x2 equals to 0. These two values are entered into the graph. So x1 equals to 0 and x2 equals to 6. So x1 means x1 this and x2. So x1 equals to 0 and x2 equals to 6. 0 means this is 0, x1 0 and x2 is 6. So x1. Next, x1 equals to 12 and x2 equals to 0. So now put the dot, x1 equals to 12 and x2 equals to 0. Draw the as it is 0 comma 6 and 0 comma 12. Draw the line. Second constant convert into the equation format. This is 8x1 plus 8x2 equals to 8. This is the second equation. X1 equals to 0 and x2 equals to find out the value. X as it is, substitute the above equation. x1 plus 8x2 equals to 80. x1 means 0. So 80 plus 8x2 equals to 80. So 8 into 0 equals to 0. We have only 8x2 equals to 80. So x2 equals to 80 by 8. So x2 equals to 10. When x1 equals to we don't know and x2 equals to 0. So substitute the same format. Plus 8 into 0 equals to 80. 8x1 equals to 80. x1 equals to 80 by 8. 8 ones are 8 tens. So x1 equals to 10. So we got two values, x1 equals to 0, x1 equals to 0 and x2 equals to 10, and this is the x1 equals to we don't know and x2 equals 0, x2 equals to 0 and x1 equals to 10. So this in this equation we got 2 points. We have to substitute in the graph. So x1 equals to 0. So x2 equals to 10, 0 comma 10 we have put, and x2 equals to 10. So x2 equals to 10 and x1 equals to 0, x2 equals to 10, 0 comma 10 and x1 equals to 10 and x2 equals to 0. So we have to draw this line and find out the feasible reason. First constant less than or equals to and second constant less than or equals to, and you have to find the feasible region. Feasible region should be below the lines. So which you have draw the feasible lines. This line first constant and the second constant. So below the కాబట్టి సో మనం ఇది feasible region గా తీసుకుంటాము. In order to find the feasible lines, both constants less than or equals to, the feasible region should be below the two lines. So select this is not suitable and this is not suitable. So the below these two constants means this is the feasible region. So have to put names A, B, C, D. These are the A, B, C, D. And find out the maximization z equals to 12x1 plus 16x2. So enter the ZA and ZB, ZC and ZD. So we have to enter into the 0 comma 0. Have to put x1 equals to 0 and x2 equals to 0 and A equals to 12 x1 means 0 and 16x2 this is the also 0 and 12 into 0 means 0 plus 16 into 0 means 0, this equals to 0 and B value and 10 comma 0, 10 means x2 and 0 means x1. So 12 x1 means 10, sorry, 12 into 10 plus 16 into 0, this is the final answer 120. And C value means x1 equals to 7 and x2 equals to 3. So 12 into 7 plus 16 into 3, this is the 130. So d value x1 equals to 0 and x2 equals to 6. 12 x1 plus 16 x2, x1 equals to 0 and 6 x2 equals to 6. This is 96. What is the objective function? Maximization z equals to 12x1 plus 16x2. So we have got 4 points now. So highest value taken from the optimization. So optimization value is 132. So x1 is 7, sorry, and x2 equals to 3. So x1 7 and x3 3 and optimization value is 132. Thank you for watching video.